Alright, so we're going to continue talking about triangles. And this time we're going to look at something that's very familiar to us. We're going to revisit that Pythagorean theorem and build on it. So do you remember the Pythagorean theorem? A lot of you will know that formula or that equation, a squared plus b squared equals c squared. But remember, there's some things that you need to have true or know about the triangle before you can use the Pythagorean theorem. So remember, the very first thing, a Pythagorean theorem is only good for what kind of triangle? Well, it should be the right triangle. Right? So I need to know what's a right triangle, okay? And then in addition to that, you want to know what A, B, and C are. The most important value, of course, is C, because C is the hypotenuse. Remember that hypotenuse is always the longest side, which is directly across from the right angle. And then the other two don't really matter. You can call either side A and the other leg B. Doesn't matter. But A squared plus B squared equals C squared, and you can use that whenever you have a right triangle. So let's take a look at example 1 and just revisit Pythagorean theorem. So remember, the most important thing is your C. What is the C value in this problem? Well, hopefully you're seeing that is X, because that is across from the right triangle, the right angle. Then remember, the other two sides don't really matter. It's going to be A and B, okay? So then we want to say A squared plus B squared equals C squared. Right? And then just substitute your values in. And here's where you want to be careful. Go back to your algebra 1. This is x minus 2 in parentheses squared plus 4 squared. And that whole thing equals x squared. Okay? Then remember, this is not x squared minus 4. Definitely don't just square both terms. Think about FOIL. Remember, this is x minus 1 times x minus 1. And it's good to just remember that as we're going through geometry, because you're going to revisit this when you take Algebra 2 in the future. So it doesn't hurt to keep remembering those Algebra 1 skills as we go through our math. Okay? So I'm just going to go ahead and FOIL. And remember, if you don't remember FOIL, it's first, outer, inner, last. Or you can make the box. It's up to you. But I'm going to get x squared minus 2x plus 1 plus 16 is equal to x squared. Oops. All right. And then let's solve. And notice something very convenient will happen. Let me just combine my like terms first, and I'll continue my work up here. So x squared minus 2x plus 17 is equal to x squared. And something very neat happens, right? If you're worrying about that x squared and wondering, whoa, do I have to factor? What do I have to do here? Well, if I take away x squared from both sides, they're eliminated. So then I get negative 2x plus 17 is equal to 0. And then I just subtract 17 from both sides and then solve for x. So x equals positive 17 over 2. Or you can write 8.5. Again, just showing you how the Pythagorean theorem doesn't just have to be with 3 numbers. It can be with expressions, so we want to be comfortable dealing with things like 2x plus 3 or x minus 4, you know, those types of things. All right? So let's go ahead and now talk about what is the Pythagorean triple. But remember, for the Pythagorean theorem to work, we have a right triangle, and a right triangle has, of course, 3 sides. So Pythagorean triple is basically 3 numbers that make the Pythagorean theorem true. So again, any numbers a, b, and c that fit that equation, a squared plus b squared equals c squared. So we can do a couple things with this. We can determine that missing side length. We can decide if sides form a Pythagorean triple, all that good stuff. All right. So let's take a look at example 2. And oops, before we do that, let's back up to that definition of the Pythagorean theorem. I forgot to include some very, very important information. They're not just any 3 numbers. So they need to be 3 numbers that are non-zero whole numbers. So do you guys remember what whole numbers are? Whole numbers are things like 1, 2, 3. So basically natural numbers here. We want things that are not 0, but are actual whole numbers. So not decimals like 1.5, not fractions like 7 over 3, not irrational numbers like the square root of 2, but we want actual whole numbers like 3, 4, 5. And those are Pythagorean triples. So when you look at example 2, that's where that second part of the directions comes in, right? tell if the side lengths form a Pythagorean triple, we need them to be whole numbers to be a Pythagorean triple. Alright, so what we can do with example 2, part A and B, both of these, is try to first figure out what is the missing value. Are we missing A, B, or C, right? And then see if we end up with 3 whole numbers that are obviously positive and non-zero, and then we can say it's a Pythagorean triple or not. So if you look at A, what are we looking for? One of the legs, A or B, or the hypotenuse, C? Well, obviously we're looking for what's across from the right angle, so that is C. So that means it doesn't matter which one you pick as A and B, but these are your 2 legs. So set up your equation. 14 squared plus 48 squared, that should equal C squared, right? And then it's just a matter of doing some math. So we know 14 squared is 196. Oops. And then 48 squared is 2,304. Oops. I meant 2,304, not 2034. And that equals C squared. So again, just finish your algebra, right? So we're going to get the square root of 2,500. Remember, because we are dealing with lengths, we don't care about the negative square root, but remember, if you're solving in algebra 1 or 2, you want to put that plus or minus sign here. But here we don't care about the negative because we're talking about an actual physical length. So square root that, and we should get 50. Alright, now is 50 a whole number? Yes. Is 50 greater than 0? Yes. So yes, 14, 48, and 50 are a Pythagorean triple. And remember that keyword explain, tell me why. So, oops, let me make this a little bit easier to read. Sorry about that, my handwriting's all over the place. So because the 3 numbers are non-zero whole numbers, such that 14, oops, let me clear that up again, such that 14 squared plus 48 squared equals 50 squared. And done. That is the explanation, that second part of example 2A. Alright? Go ahead and try B on your own, and in a moment you'll get a chance to check your answer with the question. But remember, you want to first start off with, what am I looking for? One of the legs, A or B, or the hypotenuse, C? And if we start off, looking, you should already tell what value is C here. Well, C should be 12. So use that to start off your problem. And then we'll go through and finish this off. Alright, so remember, you had to find C. So let's take a look at my work. And there we go. So remember, it doesn't matter if you label the legs A or B because those are interchangeable. C is really what has to be different. And I chose to solve for B here. You could have called it A, doesn't matter. And then notice how I did the square root of 128. That's not going to square root really easily. But you can always reduce that, right? Simplify it down to simplest radical form, which you need to do. If you don't do that, you will lose points for not simplifying as much as you can, just how you would lose points for not reducing a fraction. And if you don't remember how to go from square root of 128 to 8 square root 2, let me know, and I'll be happy to show you when we're in class. Alright? But now I've solved for the missing side. Final question. Pythagorean triple? Yes or no? What do you think? Well, hopefully you're thinking no, because what do we need to know about those numbers again? They need to be whole numbers, right? Which one of these is not a whole number? The 8 square root 2. So we'll say 4, 12, and 8 square root 2 are not a Pythagorean triple. Because, again, I'm adding because I asked you to explain. And oh my gosh, my handwriting is all messy today. Sorry about that. So it's not because 8 square root 2 is not a non-zero whole number. Excuse me. And done. That is a Pythagorean triple. Okay, moving on. Converse of the Pythagorean theorem. So, you guys remember the Pythagorean theorem. You're given a right triangle with sides A, B, and C. Excuse me. Where C is the hypotenuse. So now, what's the converse of that? Let's write this down. Alright, so there's your converse. If the sum of the squares of two sides of a triangle equal the square of the third side, then the triangle is a right triangle. So remember before, we had to be given a triangle and the three sides saying we have a right triangle with a hypotenuse C, right? But now we're saying, well, what if I was told we have a squared plus b squared equals c squared? Then what can I say about this triangle? Well, then I can say the triangle is a right triangle. So remember here again, you're given the three side lengths, but you're not told this is a right triangle. So if we know a squared plus b squared equals c squared, then the triangle is a right triangle, right? That's what we know. So again, if I wanted to call this triangle, for example, XYZ, I can say triangle XYZ is a right triangle. And remember, in addition to that, we know that the right angle is always across from that hypotenuse. So we could even say connected to that angle X is a right angle, right? So just some things you know from this converse of the Pythagorean theorem, all right? So that's one way to prove we have a right triangle. And this is useful if I asked you to prove, for example, something about, you know, using HL and you had to prove the triangle is a right triangle first. Or if you needed to find the area of a triangle and you didn't know which side was the altitude, if you can prove the triangle is a right triangle, then that one of the perpendicular sides could be the altitude that you're using for the height. So a lot of applications for this converse of the Pythagorean theorem. All right, we've got one more theorem and then one last example, and I am done talking today. Hopefully my voice will come back soon. But this next one is the Pythagorean Inequalities theorem. So let's write this down. So the Pythagorean Inequalities theorem covers the other two types of triangles. So we know the converse of the Pythagorean theorem tells us we have a right triangle, but we can have acute and obtuse triangles as well. And that Pythagorean type relationship, that a squared, b squared, and c squared, we can look at them as an inequality to tell if we have obtuse or acute. And the way I like to remember it is look at c squared, right? So remember, c is always going to be the length of the largest side, or the longest side, right? So that's always going to be that longest side, right? Okay? Now, what matters is if you can identify the longest side and you know the numbers of all three sides, if that longest side squared is still bigger than the sum of the other two, that longest side, that big guy wins. So it's an obtuse triangle, right? And I think big with obtuse, because an obtuse angle is a pretty big angle, okay? For the other side, if that longest side, c squared, is smaller than the sum of the other two, right, a squared plus b squared, then that large guy is not so large after all. The little people win, so it's acute, because acute angles are small. And that's the way I remember it, right? Looking at the less than and greater than sign and seeing if that c squared is bigger or if c squared is smaller, okay? So finally, you should be able to look at any three sides and tell me if we have obtuse, right, or acute, because we already know how to tell if you can draw a triangle with three sides. So we already know how to check that. But now, how do I know if it's obtuse, right, or acute? Remember, c is always the longest side. So what number is c here? C should be 10. So that's how you should set it up, right? We want to see c squared. How does that compare to a squared plus b squared? And work it out. 10 squared is what compared to 5 squared and 7 squared? So 125 plus 49. So we've got 100 here and 74 here. So that is less than, which makes this acute. And that is it. Come back with questions.